Okay, hi everyone. I am Takahiro Yoshida at National Institute for Environmental Study from Japan. So anyway, I love GIS. So that my icon of Facebook or Slack is this super GIS man. Do you know it? I bought a T-shirt printed with this GIS Superman in Esri user conference in 2017. It's a great honor for me to be here. Let me start my presentation. Okay. This is my research motivation. Now is an IoT era. Almost people have a smartphone every day, everywhere. Many sensors are distributed in any city. There are many spatial big data are being emerged and accumulated at this moment. In the IoT era, spatial big data are more available, I think. So we will need to consider how can we use various spatial big data for GeoDesign at any level or at any scale. And also, how should we use the spatial big data for creating a resilient, sustainable, efficient, and well-being society? As many presenters in this week, mentioned in this week, in order to design it, we will need a looping process: design, simulation, evaluation, design, simulation, evaluation, looping. Any kind of big data include real activity information, not physical information. So, example, physical information means building height and building use and road width. On the other hand, activity information means where people are gathering now, or what happened now. I think by using spatial big data, the evaluation process can be based on the performance, like a reduction of rate of CO2 emission in an area or change rate of people flows as a key performance indicators. So in this presentation, I'd like to show you some example of performance modeling and visualization on energy consumption and CO2 emission. So urban carbon mapping management is increasingly important as global warming advances. So according to the IPCC, 75% of CO2 emissions are derived from cities. Now, city managers need to system to support carbon management to achieve it, to reduce the CO2 emission. In the Paris Agreement in 2015, over 20 cities have pledged around 500 gigaton level reduction of CO2. So city managers concerned the carbon mapping approach where and when is critical point of CO2 emission. So our goal is to visualize carbon mapping using spatial big data in dynamic and three-dimensional manner as a first step to use spatial big data for carbon management. As a study area, we focus on Sumida or northeastern part of Tokyo, and this area is mixed in Japanese traditional and newly well-developed area. So this is methodology part from here. Of course, in order to visualize energy consumption and the CO2 emission, I collected the physical information like building use, building height, and something like that. On the other hand, I also, as a building activity data, so I collected Google Populartime data, one of it. Google Populartime data show how busy the points of interest are during different times of the day. The movie shows the daily rhythm and the daily pattern in the city. As you can see, this area, the right one. Okay, here. As you can see, the area is more active in the night time. So because there are many pubs and shady night clubs. So the result of Google search on this town is here. Can you imagine this night town? Very DJ, con, and disco bars, and I don't know why, but it's a very famous and popular night town in Japan. The estimate calculate time energy demand at each building level. We use three components: basic unit consumption, and the total floor area, and the popular time. So this is visualization result on a crash real-time energy demand and demand consumption. And to visualize CO2 emission in the city, we need to also consider transport sector. To do it, we collect mobile GPS data. But original GPS data do not include the tag on transportation mode. The data includes only ID, timestamp, longitude, and latitude. So to attach the transportation mode tags into the GPS data, we use the machine learning techniques to detect the transportation mode. So finally, this is the result of our CO2 mapping visualization. Red color shows a building. Blue is a road links. The height and the color describes the magnitude of CO2 emission. First, road emission rapidly increased between 6 a.m. and 9 p.m. Yeah, just now. And then the building emission is increased and continue to be large from 9 a.m. to 6 p.m. This is working hour. So the higher road emission area is a bridge over the. This is the light top right area is a bridge. This is a famous congestion bridge. Is this. So I really appreciate if this presentation could be useful for thinking how could we use the spatial big data for the design. So that's all. Thank you.